I've taken the math portion 3 times.
3 times. Okay. And what were your scores the 3 times?
30, 35, and a 50 the last time.
30, 35, and a 50. Well, that's a good upward trend, right?
Yeah, about 6 more times and I'll have enough.
If they give you credit for just like, or partial credit for each time, that way you could kind of build up, then that'd be a good deal.
I did pass the knowledge on the first time I took it, so that was
Really?
helpful.
That's
Yeah.
good. I've had people actually pass the calculation and then not pass the knowledge portion. And I think it's mainly probably just, being comfortable with reading skills and stuff, probably to some degree. But what was your secret for the reading comprehension part?
The knowledge portion, I did a lot of studying. I had bought a couple of computerized practice tests, and went through those. One from DeWalt, I had it online there, and then I had bought one from somewhere else, and I just went through it, forwards and backwards until I could find my way in the code book, really, to answers. And I'm like you, I didn't really care for I didn't care too much for the index, but I did find it somewhat helpful. I mean, it got me pointed in the right direction.
Yeah.
And I think with the amount of studying I had done beforehand, I was able to at least find my way back, to where I needed to get to instead of getting sidetracked. On the calculations, I know for a fact from the last time I took it, from this class that I took with you, I know there were a couple or more questions that I used either the exceptions or I applied things that I shouldn't have. And I once you said that in the class, I was like, you know what? I know for a fact because I would work out the problem and go back and look, oh, there's an exception, and I would apply the exception, and it didn't tell me to.
Oh
And
yeah.
so
Yeah.
I would
Yeah.
bomb it. So
Yeah, that happens a lot. I mean, if you don't know that basic rule about the Texas test, it's really going to mess with you because it can really change the way you approach the calculations of a question for sure. But I'm sure there's plenty of code sections that it changes the article as well. So,
yes, sir.
well, so what calculations do you think are you struggling with the most, or what do you want to?
Based on my test results, the electrical services, service equipment, and separately derived systems is what I've missed the most on, I guess.
That's a tough. That's probably the toughest line item to improve on too. Services, service equipment, separately derived systems. Um, the location of where you find that stuff in the code book is spread all the way through. Like it's hard to just say it's all in just chapter 2 or 3 or whatever. It's like you'll find bits and pieces throughout most of the code book, and so it's just from a breadth standpoint, it's a lot to cover, right?
Yeah. Right.
The separately derived systems, mainly grounding and bonding, is what that's going to be about. What calculations on the test did you have that were struggles for you? Was it? Do you have a particular set of categories? Do you think that are?
So on the services and load calculations for services, um, the one thing that got me, I know for sure, was they brought up a list of givens. So like it would tell you these are the appliances, fixed in place appliances, and I didn't know what to look for that.
Mm-hmm.
So I was bombed on it. I was like, well, I don't really know because it had given those numbers, and now, from your class and from the research, I know, well, there's at 4 or more, you do 75%, and you just use the nameplate rate that they give you,
Yeah.
or the rate amperage that they gave you, wattage rather, and so that's a lot of help for me right there.
Did you have were they part of a calculation for the service, or was it just the appliances listed kind of by themselves?
Yep, for the service, yeah. So they'll
Okay.
give you, square footage of the house, and all of that information, and then it listed those appliances. So water heater, dishwasher, uh, microwave, and I guess what the fourth one was. I don't remember what the fourth one was. Did I say dishwasher?
Disposal, maybe.
A disposal. Yeah, and they gave the values for them, but I wasn't sure how to apply them.
Did they give you the values in horsepower or wattage?
So they did it in wattage, but I think they did have one in horsepower, like the disposal. I think they had it in horsepower or something, and yeah, it just threw me.
Yeah, that's one of the grayer areas of service calculations, because when you include that, right, as one of the four that you derate under 220.53, then you're effectively taking a 25% derate off of that motor, right? I mean, effectively that'd be the fourth one, which would enact 25% across all of them, but the motor itself would be 25% off. But then look at 220.18A in your code book, which requires you to take 125% of the biggest motor listed in the load calculation, greater than, what is it, 1/8 of a horsepower, which typically your disposals are greater than that. So then, what do I take that first at 125% and then derate it by 25% to get 100% of it? I mean, how does that work? Like, can I derate it in one group and then take additional 25% of it in another? Like, the code doesn't really specify kind of how to deal with those, and it's always interesting to me how they include a motor, because they know that's kind of a gray piece. For me, yes, you can derate it in the spirit of the overall load calculations for that. However, you should also include, though, in your calculations a 25% based off of 100% of it before you took the derating to tack on for the motor startup itself. So I would do two things. I would do the disposal at 125% first, right? Actually, not 125, just 25%. And I would put that 25% total over here on the side. And then as a second calculation, take all four of those at 75% and then put that group there value that's been derated. That way you have the full 25% for the one motor load added as you should, but then you don't get penalized for not being able to include it with the fast in place appliances section.
Right.
So
okay. Yeah, I made some notes on that on page 321. Fast in place appliances.
Okay, so you know how to convert that then from horsepower to watts or VA.
Yeah, your horsepower times, in this case it was 115 volts, so horsepower times 115 gives me 9.8.
So 430 what is that, 248 page 321 on the 2017?
Yes, sir.
And then what is that? Let's say if it's a half horsepower, for example, under the 115 volt line would be what amps?
9.8.
9.8 amps. So then 9.8 amps times the 115 volts would give you whatever that wattage is.
1127.
So 1127 times 1 1/4 or times 0.25, because you're going to keep the 0.25 kind of as a separate line item.
Right.
I got a calculator here somewhere.
281.75.
Okay, so we'll call it 282. So we have 282 watts, or 282 VA, I should say, to be fair. And that's going to be what we keep of this factor here for the motor. So that this comes out of the 220.18 is where that would be found. So 220.18A. And then the 1172 would then go in the pile with the 1200 watt microwave and the 2400 watt dishwasher and the 5,000 watt water heater, whatever it might be, just as whatever numbers they give you. And then we take 75% of that group then as a step. There will be some people that would argue that you don't have to include it if you're derating it, because if you factor it as a deratable number, then why would you then turn around and increase it as an increasing factor for the motor load? But the reality of it is that motor starts, you have to have that extra room kind of built into the equation. So you can derate it, but you're just not going to derate that one as much as you would if it weren't a motor.
Right.
But I mean, technically the disposal is also a motor, and the microwave's got a motor in it too. So I mean, to some degree they're kind of technically all motor. Well, the water heater wouldn't be. There'd be only non-motor operated load, but at any rate, it's just be careful, because you can't put the dryer, the range, air conditioning, or heating in that 220.53. That's the only section that you can't include in that block.
Okay.
Each one of those has their own section of tables or whatever.
Okay.
Were they asking you for the total VA for that question? Were they asking you for the wire size? Were they asking for the ground size? What were they asking
The
at
total
the end?
VA. The total VA.
Did you have any of them? So with services, did you have any? Well, that'd be feeders. So if you had a feed, how'd you do on your feeder line right below the line 3?
Feeders. I had 3 questions and I got 1 right.
Okay, so it could be your service calculations and your services feeders are kind of in the same lump. So, you think that one that you got right was this one, or was it probably a
No,
different one?
I'm sure it was a different one. I don't remember
Okay.
which one it is, but this one, I struggled with it because of that. And then you had given an example of another calculation for multifamily, but it was just, it said the definition of the dryer. You said it had it gave you the wattages for the dryers, and then it said this is a multifamily. But I didn't know the definition of multifamily was 3 or more, so I was like, I'm lost, and that one got me for sure. I know.
So you had that question. That's pretty, or something similar to it.
Yeah.
That's interesting. Yeah, I like that question because you have to know the definition of, not only do you have to know the definition of multifamily, which is 3. Now you know that,
Right.
which a lot of people would just assume it's 2 or more, right? Because that oddball 2-family definition is kind of weird, to have such a strange 1 and 2 and then multi. But the other part about it is that the nameplate being 5,000 watts or more to use any derating of the table. Do you remember how many? Was it just did they give you the nameplate of it? Did they give you a value for it, or did they just say word dryer?
No, they gave the value for them.
Was it larger than 5,000 or less?
There was one, I think, 5,500. And I don't remember the other 2.
So they were mixed values. They weren't all the same.
Yeah, they were mixed values.
Okay.
So, can you run through? And I've made the notes, and I'm trying to keep it straight on the range calculations. I believe you had put on there. You said to write that in your book. A blank in your kilowatts minus 12 kW gives you 8,000, and then you multiply that times 0.05, and that gives you your 1 point whatever times 8,000. That comes up with your total. And I don't remember much about that now.
Are you talking about the bracket that I was using, or just the shorthand? So, ranges are kind of complex, right? I mean, that's the bottom line. And because you can use the same table for both branch calculations and service calculations, you'll find that you're going to use that top row or the top, the line 1 more often than not. So note 4, which says, okay, you can combine units together, right? So note 4 says 1 wall mount and up to 2, 1 wall mount and up to, 1 countertop and up to 2 wall mounts. So the rule is you can't use anything more than or can't be any further down on the table than row 1. So to be on row 1, it's only 1 appliance total. So if I have a 5,000 watt cooktop and a 2,500 watt wall mount and a 7,500 watt wall mount, right? As a service calculation, that's completely different because I've got 3 separate units, 2 of them that are going to be in column B and 1 of them will be in column A. So according to note 3, note 3, I would split them into their respective piles as a service calculation, right? So this one would be a column A. These would both be column B. I would do this pair at 65% and this one at 80%, right? Do all the math, combine them, and get an answer. And then just out of curiosity, I wonder what this would be. I like to always kind of compare the 2 methods. So we'd have 75 and 5 would be 12.5 times 0.65 would give us 81.25, right? and then we'd have 80% of 2,500, which would be 2,000, I think. Yeah. So then we take the 2,000 and the 8125, so it'd be 10,125, right?
Okay.
So I'm doing that because I'm always kind of curious how the two different things match up. So as a service calculation, they're each individual units, but if I do them as a branch calculation, and I only am allowed to use row 1, that means that what's happening here is I'm going to have to add all these ranges together and pretend like they're one gigantic big range. And so that's why you move into column C then as opposed to being an A and B like we were a minute ago. So let's see, as a column C at 5,000 plus 7,500 plus the 2,500, we have a gigantic range that's equal to 15,000 watts, right?
Right.
So on row 1, the thing is, and I'm just going to, so on row 1, I've got a 15,000 watt range. Under column C, I've got a demand factor or demand load that's already been calculated for me. So that 8,000 watts that you see there is already predetermined. Somebody did that for me. Mm-hmm. So all I need to do then is get this number here to this number here plus whatever I went off the chart, because the chart's only good for the first 12 kW, right?
Yes.
So if that first 12 kW is going to equal that 8,000 watts, well, then the first thing I'm going to do is take that 12,000 as the first 12, and I'm going to subtract that 8,000. I'm going to substitute, I should say, the 8,000 watts for that first block of 12 kW of the nameplate. So that nameplate and then the demand load that's already calculated, that's an even swap. So I would literally then just be done with that part and only then have to figure out, well, whatever I went beyond that nameplate rating or beyond that 12 kW that the column's good for, I have to process that out. So right. I've got 3 single kW steps past or beyond the limits to column C, which were the 12 kW. Mm-hmm. So for each one of these down here, the 3,000, I'm going to have to take a 5% increase of that 8,000 watts. So it's really, I always just kind of remember, I've just got to put 5% there, basically is what that is. So I know that I'm doing 3 times 0.05, which is going to give me the same thing as doing as 1.15, right?
Right.
So I then turn around and do 8,000 times 1.15, and that would give me 9,600, is it?
9,200.
9,200, sorry. Tried to get too slick with myself. Yeah. What did we have on the original 10,125 versus 9,200? Same 3 appliances, but they can give you 2 different answers.
And this is for branch.
This is for a branch. That's right. Because I can combine them together as a branch calculation. I can't. I don't combine them as a service. They're always their own line item, right? And I deal with them whatever row they belong or whatever column they belong. I have to deal with each one of them individually or as a group. Right. But here it's the same thing as row 1. Now on row 1, so the way I did it in class to kind of try to help you remember it was I put that this right here was always going to be the same, right? This was always going to be the same. And basically what I said was just you don't have to do the watts. You can just do the K value, right? So I put KW here. So this is then going to be always 12 kW because that's always going to be the same part. Mm-hmm. And so all you're going to have to do then is basically take the stuff that is not in blue here and just process it out. So really there's only 3 things that you're having to include. You're having to include this, which is your total nameplate for all of the ranges combined, the difference between the 2 of them, and then when you process that difference of 3 times the 5% for each one of them, just plug that in right there. And so you end up with effectively 3 steps, I guess, if you want to look at it like that.
Yeah.
This format's easy to follow along with. It's easy to write it down that way. It kind of naturally kind of keeps them straight. So that's what I said, to just put it in the back of your book somewhere and leave the 3 spots blank. So you leave, this one blank here, you'd leave that one blank, and you'd leave that one blank. And then this will always be your answer, this 9,200 or whatever it might be. But this format right here is an easy way to kind of keep track of it for me. It seems like Otherwise, I'm having to remember all of these steps independently.
Mm-hmm.
So
No, that makes sense. And I put it in my notes um, in my book. I just wanted to make sure I had it straight.
now there's one more thing about this whole deal is that this number right here can be a variable, right? So once you get used to using this kind of, I guess, frame or format or whatever, the other good thing about it is that if you get past column C further down the chart, but you get ranges that are 15 or 20 of them or whatever, but they're way bigger than 12 kW, the handy thing about doing it this way is this will help you with those calculations as well. You just got to remember that you would then have to enter whatever that column C value is right here. So this would then become a variable for you. But the rest
Okay.
of it's still the same, right? So for
Right.
example, let's say that we had a total of 20 ranges and they were bigger than 12 kW. Let's say they were crazy. They were 16 kW. That's
Okay.
not impossible to think might happen. So, all right, well, I go to column C, right? And I know that on row 20 for columns for 20 kW for 20 ranges in column C, I'm looking at, don't tell me, C, B20, B30, 30, no, it's 25?
35%.
35. Is it 35?
35 for, number of appliances.
Is 35 at 20?
30, 35, yeah.
Not that I don't believe you, but I don't believe you.
No.
I believe you. So it'd be on column C. Then you're saying it's 35,000 watts is what you're saying
Yes.
for 20.
For 20.
Yeah, because 5 is going to be 10. 10 would be 20. 20 would be 35. Really?
5 is 20. 10 is 25.
Oh, 25. Okay, that's all right. All right. Okay. All right. So 35,000. So that number right there, that 35,000 is what you're going to put right here.
Okay.
That's the only difference. So the 16 then would go here. The difference, which would be 4, would go there. And then the 4 times 5, you'd write that in right there. And then these two numbers here multiplied against each other are the answer.
Here's your total VA.
Yeah.
Okay.
So it'd be 35 plus another 7. So it'd be 42,000.
Yeah.
Do you have one that had like 35 ranges that were 15K or anything like that? Or did you have 3 phase calculations on a range question?
I think there was the 35 ranges. Yeah.
It's like 15,000 watts or something, or?
Yeah. That sounds familiar. I'm not sure if that was a practice test somewhere or that was actually on the test though.
This is one I've heard of, so I'm never sure what the actual nameplate rating of them is, but I want to say it was like 16 or 15 kW. We'll just do them at 15 kW. I mean, if they were at 12 kW, let's do that first. If they were at 12 kW, right? Then it makes it a little bit easier because all I'm going to do then is process the math that's in column C. And if you look down at the bottom of column C, it tells you that it's what, 15 kW, right?
Yes.
And then plus 1 kW per each range.
For each range, yes.
So it's really, for some reason, people tend to get confused with this, but it's fairly simple. This block right here, you get every time, no matter how many it is. I mean, if you're within that number of ranges that row represents, which for column C is quite a few of them. I think it's what, 26 is it?
26 to 40, yeah, basically.
So yeah, anything in that area would hit you with that 15 kW right off the bat. Just bam, you got that as a block. Mm-hmm. And then whatever number of ranges they give you, I mean, if it's 60 or if it's 40, then you put in 40,000. If it's 20, you put in 20,000. Or I'm sorry, 20 or 30, it'd be 30,000. In this case, 35 ranges would be 35,000. But for some reason, people want to take that 15 kW out of the number of ranges, right? Like they're trying to convert that 35 to 35 kW or something and then take the 15 from it, but that's not how it works. The 15 is the block that you get just because you're there. And then if you have 35 ranges, then that's times 35. So it'd be 15 plus 35 total, right?
Right.
And that would give you 50 kW.
50 kW.
or 50,000 watts. Now that is the demand in column C, so it makes sense because what is the demand factor for 25 ranges?
40.
And what would it be for 15 ranges?
30.
So it even makes sense because I mean you went up 10 ranges and you went up 10,000 watts, right? On both, because at 15 you had 20 and then 30 and then 50. Sorry, 30, 40, and 50. So that 50,000 is just another number on row 35. That's what it would be if they would have spelled it all out, right?
Mm-hmm.
So that then becomes the piece of the next part. So if all of this then was just to get, at the end of the day, all of that we just did right there was just to get this number
50,000.
right here, right?
Right.
So then I go back to my example here where it was 15 kW instead of 12 kW. So then the 15, remember the part that's going to be always the same as this part, which is going to equal, in this case, what are we going to put in right here?
For 15, we're going to put in 30.
Well, remember we have 35 ranges, right?
Oh, I'm sorry. For 35 ranges, we're going to put in 15 kW, so 15,000.
So no, if you have 35 ranges, you're gonna put the total amount that you have in column C, which the total amount you have in column C is this number right here.
Oh, okay.
So that's the number that's basically the base amount that you calculate, but that's only good for the first 12,000 watts, right?
Okay.
So then that just puts us right back where we were at a minute ago, where we have the 15 kW. Then the average nameplate goes away. The number of ranges goes away once we've got this 50 kW. The number of ranges is no longer relevant because we're going to put it right there in that box.
Okay.
And then we're just back to just a single average nameplate of the units, just one unit basically. So 15 kW, then I put it in the bracket. 15 from 12 kW. Remember the first 12 of the table is good for 50. Right. So then we end up with 3 extra at 0.05. Then it'd be, 0.15, not 0.05. So then you'd multiply 50,000 times 1.15, and that would be your adjusted total if you had more than 12 kW ranges in the group.
Okay. 57.5.
Yeah, 57.5.
Okay.
It's for me, when it gets into multiple ranges, you have to be a little bit more careful, but that bracket will help because if nothing else, it'll kind of keep you straight with like the steps, right? Mm-hmm. You just got to remember to not, you just got to be in the right column when you get started. So if you're doing a branch, that's the only time you combine them, right? If you're doing service calculations, then each one of them is their own unit. So, as a service calculation, you may be way down on the chart, but as a branch, you can only be on row 1.
Okay.
So it's always kind of, when I do range calculations, it's the very first question I ask myself because they can kind of play a little bit with the word demand load and maybe be coy about whether or not they're talking about a service, calculation, but they can't hide the word branch. There's only one way to call a branch, and that's to call it a branch, right? So if you see that word in a range question, that's a red flag to kind of slow down and make sure you're adding and combining the ranges together. But there can't be more than 3 that are combined. And if you do those 3 as a combined value and there's a 4th one, it's not going to happen.
Right. Okay.
What else? Did you have a 3-phase, like 20 ranges that were in a 3-phase service or anything like that? Did we talk about that one in class?
I didn't make any notes on that one.
So there is a real common one they're asking right now, and it's fortunately in the back of the code book. It is. I'm gonna have to get my code book out. I thought I was going to try to get away with not having to have my code book all night and do it all from memory. 15. How were you doing on your time? Did you have plenty of time?
No, I probably had maybe 10 minutes, maybe less than 10 minutes left.
Okay. All right. So you used quite a bit of your you didn't get up early or nothing. So, did you have, were your answers, how did you feel before you ended the test and knew what you made? How were you feeling you were doing? Were you finding answers that were matching up or pretty confident about it or?
Yeah, I was confident. except for the few that threw me for sure, because I knew I just took a wild educated guess,
Yeah.
uneducated guess, I guess. But my confidence, because like you mentioned in class, they put answers in there that are an answer when you do it wrong.
Yeah.
you
Yeah.
know, so I was running through there putting them in, thinking, oh yeah, I got it. That makes sense. That's in there. But yeah,
Did you
that
go through
doesn't
them all?
always.
Well, I'm sorry, I didn't mean to cut you off.
No.
Did you go through all of them relatively quickly the first time and then go back, or did you just do them one at a time, or what was your?
I did them one at a time. I skipped, I think, one or two and then went back. But other than that, I just took them one at a time.
I mean, at least you had time though to look at all of them though, right? So you weren't
Yeah.
okay. Is it the ones that were really complicated? What were those? Do you remember? Were they service calculations, or do you remember what the type of calculation they were?
No, I don't.
Okay.
I'm sorry.
It's okay. I was just kind of trying to figure out if it was ground and bonding or what the topic was maybe. All right. So if you look at 220.55, and I'm actually talking about the article, not the table, right? So remember, every table's got an article that controls it that's got the same number. So if the range table is 220.55, then the article that controls it would have the same number, and you'll see it on page 73.
Yes, sir.
And the article didn't really have a whole lot of new information that you didn't already know. But if you look at the top right-hand column, right underneath that table that's up there, right underneath the dryer table, that paragraph that's underneath the table is actually the remaining steps of the 220.55. And they're talking about how you calculate two or more single-phase ranges where you have a three-phase distribution to feed them from.
Okay.
So I'm on the right-hand column, page 73, kind of just right underneath the dryer table, where two or more single-phase ranges supplied by three-phase, four-wire feeder service. The total load is calculated on the basis of twice the maximum number connected between any two phases. So twice the number connected between any two phases, right?
Okay.
So if I have 20 ranges, let's just say that we had 20 ranges, and of those 20 ranges, let's say that they're just 12 kW. I don't want to do anything crazy to you right now. Let's just leave it at 12. So if I have a three-phase distribution and I have a range that is basically an A and a B, right? And then I've got a range that would then be a B and a C if I'm balancing them.
Mm-hmm.
Makes sense? And then the third one would be right here where it'd be a C and an A. That way I would evenly distribute those ranges across the three phases that are given in the distribution. So what that means is that I'm going to take this 20 and I'm going to evenly distribute them as evenly as I can across those three piles, right? To balance it the best we can, which means the only way to split 20 into three sums would be like 6, 7, and 7, I think, right before you'd be 20. So what they're trying to say then is where this occurs, the total load is calculated on basis of twice the maximum number connected between any two phases. So the maximum number between any two phases would be whatever that biggest distribution would be. In this case, 7.
Mm-hmm.
Does that make sense so far?
Yes.
Sort of?
Yeah, I got it.
Okay.
Yeah,
I lost the sound. I don't know what I did to mess up. Is that me?
Can you hear me?
Let me see here. Oh, I did. I put myself on mute somehow or another.
Uh-oh.
Can you say something?
Yeah, can you hear me now? No?
Let's try this one. Say something again.
Can you hear me? No?
Let me
Testing. Hello.
check my audio. I did something here. Oh, here we go. Okay. You're back.
Yeah. There I am. Okay.
Yeah, I must have hit that button or something. Let me change my speakers to something different so I can take this infernal thing off here. Can you still hear me though?
Yes.
Probably not. Okay, you have it clear? I'll just leave it right there. All right, so the 7 being the largest between any two phases, what they're saying is that you're going to base it on twice that number.
Okay. 14.
So it'd be 14. And that's then the number that I use to go to table C, or the table to get the value out of column C. Because remember, there are 12 kW ranges, so those would be column C. 14 of them would have a demand of 29,000.
Okay.
And so 29,000, if you think about it, this 7 right here would have 29,000 VA based off of that instruction, twice the number between any two phases. Well, now this 29,000 then would be the product, remember, of phase C and phase B, the way I've got it drawn. You'd agree?
Yes.
So effectively then, if I divide that number by 2, that would give me the demand on each one of the 2 legs that are in that 2-pole circuit. So that would be what? 14.5? So then C phase would be 14.5. B phase would be 14.5. And if I wanted to get the equivalent of the 3-phase demand load, guess what I would do? Add 14.5 for the A phase, right? And that's going to give me the net equivalent 3-phase load then of 43.5 kVA. And that's what they call the net equivalent 3-phase load when you have single phase ranges on a 3-phase distribution. But guess what? Luckily, it even tells you though right there at the bottom, don't worry if you don't remember all that, no problem. You got an Annex D5, Annex D, I think is what it says. See the examples in informative Annex D. And I want to say it's D5A, but it's back here on page 798. And the example I gave you is on the right-hand column on page 798 of your 2017. Page 798. And then it is bottom right-hand. It says 40 dwelling, 20 of them with ranges that are 12 kW. And it spells out exactly what we just did there. So, I mean, you don't have to really know how to do it. If you have that question, you'll be able to just go straight over there and look it up. There's also right above there's 10, an example of 10 ranges. So if you have a question that only has 10, no problem. Get that covered too.
Cool. Yeah. That's good to know.
That's all I know about the weird range questions. I mean, unless there's another one that you really remember, I'll caution you. There is a limit to that branch circuit stuff. So if you go back to the table real quickly, look at the notes to the table.
Okay.
So when we combine stuff and we go past 12 kW, we start taking 5% for every additional kW, and so that's what Note 1 tells you to do. But the caveat is that Note 1 stops at a 27 kW range. So if you have a range larger than 27 kW, you cannot use Note 1 on the calculation for that range. Nor could you use Note 2 for that matter, because they're both capped at 27 kW. So just be careful of that. I mean, at that point, there would be nameplate rating at 100% is what you'd have. You wouldn't have any other manner to figure out any lesser or lower value for it.
Okay. 1 and 2 stops there. Okay. Very good.
How'd you do on your grounding and bonding? Were you pretty comfortable with those? Did you have a lot of those or any of those? Jumper sizing, bonding jumpers, system bonding jumpers, supply size bonding jumpers?
No, I don't have any real problem with that. Even in class, I didn't. I mean, I understand it pretty good.
Okay. Wiring capacity, breaker sizing.
So, breaker sizing, wiring capacity.
Did you have a question that was like a motor load that was in an ambient temperature, and you're trying to figure out the correct size wire for it or something like that? Like they gave you like a 50 or 60 amp continuous duty motor load with a ambient temperature.
Yeah, that sounds familiar.
Let's see what you're made of.
Oh boy.
Let's say you had a motor, and that
Okay.
motor was rated for an FLA of we'll go crazy. We'll say 79 amps. It's continuous duty.
Okay.
And I want to know what size, minimum size, copper 75-degree conductor. But you have an ambient temperature of, you know what the wet bulb was? Where do you live?
Corpus Christi.
Oh my God, it's humid out there. It's not. Is it about the same as Houston temperature was?
Yeah. Yes,
so
sir.
we'll call it 99 degrees Fahrenheit. What would be the minimum size wire for that?
So 79 amp. It's continuous duty. And you said ambient temperature of what?
99 degrees Fahrenheit. So the ambient temperature table, you remember where that's at?
Not top of my head.
Page 147. 31015 B2A, but only for about 2 more weeks.
Then it's changing it.
Yeah, it's kind of, just they changed the number of the table. They made it a little bit more easier to memorize, to be honest. But, all right. So what you've got here is a 79 amp load. And you were right. I think you already said that you'd have what did you say?
125% of 79 is 98. It's 98.75.
98.75. That would be a number 3 if you didn't have to derate it, right?
And you go to your ambient temperature column. About halfway down, that's 99 degrees Fahrenheit. So times 0.88.
Times 0.88 against what? Against the 98.75?
Yes.
So times 0.88.
86.9.
Yep. So you would multiply that times 0.88. And what does that do to your number?
That's 86.9.
All right. So
amps.
What you just did there was, so if you think about it, you've got a wire. So you have a motor that's going to require at least 98.75 amps, right?
Right.
So if you derate that motor load and make it smaller to 86.9 and size your wire to that, then what's that going to do to your wire size? That's going to be choking it even worse. You're making a bad condition even worse if you try to derate that load, because the load's got to be 98.75 all day. Like that's your solid number. You got to have at least that capacity.
Okay.
So the derate part doesn't go against the load, I guess is my point. You want to make sure it goes against the value of whatever the branch circuit wire that you're going to propose to install it. That 88% would normally then go to, you basically go to page 150, your ampacity table, which is 31015 B16, right?
Yeah.
So under the 75 degrees Celsius column, a number 3 is good for 100 amps. Now, right. I know that the 88% that I'm going to take is going to go against that 100 amps because that's the value that I multiplied against. But I can tell you right now, 100 amps times 88% is not going to be enough to get 98.75 amps. So it's going to end up being 88 amps. I'm going to take 100 amps of a number 3. I would multiply that times the 0.88. That's where that goes. They give me 88 amps. So that wire would only be good for 88 amps, but I need 98.75.
Right.
So then I would go to the next wire size, which would be a number 2. So I'd go 100 115, is it? What's the number 2? 115 or 1?
Number 2 is 115.
Okay, so go to number 2 and do 88% of that and see if that's big enough. And that's 101.2. So that is that right? Did I do that right? 101.2. So that'd be good. So we just need to go to a number 2, which is good for 101.2 amps, right?
Could you have divided that?
Yes, I could have. Very good. Very, very good. Very good. Did you already know that? That's pretty smart.
No, you told me that in class, and I was trying to figure that out. So 98.75 divided by 88.88.
There you go. Yeah, the opposite. That's where that works, because the opposite operation of multiplication is division. So
we came up with 112.23,
which
so
is
that's not a 1/0, but it's close enough to a number 1.
No, what is it? How much?
I'm sorry. 112.21. So
would fit very nicely with the number 2, wouldn't it?
Number 2, yeah.
Yeah. So it just skips a step of having to guess at the wire and derate it until you figure out which one it is. You just divide it by the factor and then pick the next larger wire on page 150 and call it a day. That's the same amount of movement proportionately that you lost against the wire, you gained it against your load. So it'll always work out mathematically the same wire size, but it's a lot faster.
Okay.
So divide that by 0.88, and that was the 112.215. So, and that's the movement that you want. You want that number to get bigger instead of smaller like this one was, right?
Yeah, we went the wrong direction. Too big a hurry.
Well, I see that happen a lot. That one particular question gets a lot of folks because they do that same thing. Because mentally you're starting on this side of the equation and you're calculating, and then you stop, you go to another table, you kind of forget what you just did. You get back to it, and you're like, okay, there's the number, here's the multiplier, and you do what you just did. But just remember that would be either a divider, or you'd have to go to the wires and just start trying them on for size one at a time. I kind of like that question. I think it's pretty interesting. But at any rate, what else? Give me something hard.
Oh Lord, I don't have anything hard for you, man.
Trust me, there's plenty. What question just really stumped you, or what did you do? Do you have RV parks, multi-outlet assemblies, condo fill?
Multi-outlet assembly, I know that was difficult, but after your class, it made more sense. The RV parks, I kind of understand that. I mean, I don't think I had any problems with it. But the multi-outlet assemblies, I'm sure I didn't count. Once you reach that major fraction of the next one, I didn't count it, so I was off.
Yeah.
I gotta remember. I have to remember that if it's on the test again.
Yeah.
And if it's a major fraction of the next 5, then we got to add it. So.
Yeah, I think that is so those questions, those multi-outlet assemblies, they've been on every master's test since the dawn of time. I don't know why, but they love that. I guess it's because it's kind of an oddball calculation. But did you have any show windows or anything like that?
I did on one of the tests, the show windows, but I think I got that one figured out. I mean,
you remember how many feet it was?
No, I don't remember now.
Well, if you had 22 feet, right, what would be your demand load on your service or branch circuit for that 22 feet?
22 feet of show window. All right. I don't know. That's not an answer.
220, Article 220 would be where you get a lot of your calculations, right? I mean, so if you ever have any branch or feeders, that'd be the first place I'd start, because 220 is got a ton of branch stuff, and then you get into feeders in part 3. But this is this is show windows is 220.14. I want to say G or F. I can't remember which one it is.
22 feet. That's 250 watts.
Oh, you got the 250. Oh, you're already up. Yeah, that's enough. I don't need to do anything else. You got the 250. That's good enough. What about service calculations? Do you have any service calculations?
Oh, I know I did. I don't know how well I did with them.
And you said they're pretty complicated.
Yes, sir.
Let me see if I can pull one up. I got some samples here. Save me from having to subject you to my awful penmanship. Let me see here. I'm going to see if I can just share my screen here. Ignore all my porn. Let's see here. So this one right here. So this is basically that little chart, that I showed you a minute ago, which I think that's the neatest way to kind of figure this stuff out. That looks way overcomplicated from the way it really is when you use it, but at any rate. All right, so let's go down here and look at, I do have some that are pretty detailed. So let's see here. That's an optional method. Let's see here. Let's try one that is not an optional. Let's see. Maybe the only one I have on this slide. If this was not an optional method, if it was a standard method, let's do a standard method, and then we'll figure out. Is this too much, or did you have one that had a lot of stuff like this, or?
No, there was one with a lot of information.
Can you see that screen? I mean, can you see that?
Yes. Okay. So 3750 times 3 VA.
Question like that would burn a lot of time too.
Yeah, it does. It takes time just to even read it.
Yeah. And then, you've got such a small, scratch paper, if you want to call it that.
Right.
It's really kind of a headache. Let's see if all right. You done?
Oh, no. No.
Got jokes.
Take me too long.
It's going to be easy. So if we do a standard method.
So I have a question with this. Since it doesn't specifically tell you in this question, it doesn't specifically say to have the general things that you should have in a dwelling, like your small appliance circuit and your laundry circuit. My inkling is I would put that in there because it would need to have it, but it doesn't say to have it in there.
Trust your inklings. They're very good. They're working.
Okay.
So what you're talking about is the minimum required circuits, right?
Right.
And there's physically 5 of them, but from a load calculation standpoint, only 3 of them count. And that's the 2 small appliances in the kitchen and the 1 laundry, and you nailed it. So it's $1,500 each, and those always, no matter what, whether it's a mobile home or a fast in place home, that $4,500 is always kind of a given. The only time you would ever exclude one of them is in a multifamily calculation, and that's if they have like a common laundry facility. Then you can drop the 1,500 VA off for the laundry. But beyond that, there's no allowance to forget or forgive them.
Okay.
So we're gonna do this as a standard. Oh, it's not showing you my presentation. It didn't carry over, did it?
Yeah, you were writing on their standard.
Oh, you can see that?
Yes, sir.
Okay, all right. All right, so what was your first step then?
So 3,750 times 3 VA gives me 11,250.
Okay.
And then my 2 small appliance and my laundry gives me another 4,500.
Yep, right on.
Brings me up to 15,750 there.
15,750.
And then I take 3,000 off of that.
Mm-hmm.
I'm going to keep that 3,000, but the rest of that 3,000 I'm going to multiply times 35%.
Yep.
Which gives me 4,462.50. Added to my 3,000, I got 74,62.50.
How much was it? 44 what?
44,62.50.
Okay, in 0.5. And then you added the 3,000 back.
Yes, sir.
74,63, we'll call it.
Okay.
Then what?
Let's see. Now that's where I'm at now. So now I've got my dryer. Where do we see? Contains a range 4,500 watt dryer. So we have to do 5,000 because that's minimum, right?
That's, yeah. So as the standard method, yes, you would have to do the minimum 5,000. So you would then you're doing the dryer first, right? So that would then be plus 5,000 for the dryer. Nothing less than 5,000. Oh, just disappeared. What happened? Got booted out. Let's see here. Okay. So oops. Mute myself. Okay, so we have 7463 for the lights and plugs. Then you did the dryer next, is what you said, and the dryer then would be 5,000 watts. And 1 through 4, there's no derating, so we just tack 5,000, so plus 5K. So 7463 plus 5,000 so far. Now what?
I need to find my dishwasher, my garbage disposal. They give me horsepower, so I have to find out that chart small appliances again.
Yeah, the dishwasher and the disposal will both be 120 volts, so you could just add them together and do 3 horsepower. Will it work that way? I don't think so. I don't think it might, but I don't. If it does, I wouldn't rely on that on the test. I'd probably do them separately. I'm just saying. It'd be probably pretty close, but let's see here. It might actually work. We'll see. If I have a 2 horsepower and no, that's not gonna be exactly right. So you'd have 24, but you could take 24 plus the 16 together and then multiply times 115. That would be the same. So 24 plus 16 times 1.15 or 115, excuse me. It's a 2 horsepower.
24 volt plus 16 times what do you say? I'm sorry.
115 volts.
4,600. 4,600 times your 25%.
Yeah. 5,750 would be your total, right, for that. Now, that's 5,750. That's with the full 100% of the motor already calculated in there, which was the 4,600 or whatever it was, right? Now, if you have 4 or more fast in place appliances, you don't want to do it that way, because then you're going to have to turn around and extract that, put it in with the other fast in place appliances, and then derate it by 75%. In this case, you've got the dishwasher, the disposal, the dryer, another dryer, and a water heater. Now, I can't use the dishwasher. I can't use the dryers, but I do have a dishwasher. So I've got a dishwasher, a disposal, a water heater.
That's all we got.
Yeah, you might. I mean, you could almost consider that blower motor to be a fast in place appliance, but it's not really a separate appliance by itself. It's part of the AC unit, so I wouldn't count it. So there's not anything but 3, which means we're just going to keep 100%. So what we did with that 5,750 would be fine, right?
5,750.
Now, if there would have been 4, though, I would have only done 25%. So I would have done the 40 amps combined times 115. So together, they're 4,600 straight across at 100%, 4,600 watts. That 4,600 watts would have then been added with the other fast in place appliances, and then taken a 75% derate if I had 4 more. Since I don't, we just leave it in there with 5,750. So then you add and actually I just realized there's 2 dryers. There's this 4,500 watt and then another 4,500 watt. So there's actually a total of
5,000.
Yeah, 10,000. So, so then the disposal and the dishwasher are the 5,750. That leaves us with just the range, the fan, the blower fan, and the air conditioner heat package. What do we do for the range?
Okay, on our range, 15 kW. Oh, so we're going to use our bracket on our range, right?
Mm-hmm. Yep. Let me.
So we got 15, 12, it is 8.
Oh, I can't do it from there. I didn't do it from here. Let me see. Let me just borrow this for a second. Let me just, so I can see what I'm doing here. So we take the 15 kW. Here, let me put a little higher so I can have room. Minus the 12. That's what equals the 8,000 watts from column C. And then we take the difference, which is the 3 steps past the chart. Oh, did I lose you? Oh, no, you're there. I kind of blacked you out. I'm not sure what happened, but times 0.05 equals 1.15, and then that gives you the, so it was 12, so it'd be 9,200.
9,200, that's what I got.
So then we just plug that in with all the rest of the values that we had just a second ago. So we've got everything except for the air conditioning, the heating, and the air blower. Now, the air blower is always going to be on no matter whether it's the AC or the heat, right? So I have to include that. And it's a motor load, so it's a half horsepower at 120 volts. So you're going to have to convert that to volt amps, back on page 321, which is for half horsepower at 115 volts. It is. You believe I don't have tabs in my own book.
9.8.
I sell tabs. What is it? 9.8.
9.8.
9.8 times 1.15. 1127. 1127, sorry. And then the larger of the two, so 220.60 says that when I have coinciding loads, in other words, that they don't both operate at the same time. In fact, they're typically interlocked, so only one will operate at any given time. So 220.60 says I can omit the smaller of the two loads. That's on page 73. So I'm just going to drop the smaller between the AC or the heater.
So we'll just take the heater at 20 kW.
And heating loads are kind of funky because they're continuous duty on a branch calculation, but they're not continuous duty on a feeder calculation with the standard method. So as a standard method of calculation under 220.51, you keep 100%, but as a branch under 424.3b, they call it out as a continuous duty on a branch. But so 220.51 on page 73, top left-hand corner.
100% of the load. Yeah. So we just add that 20 kW.
Huh?
So we just add that 20 kW.
Yeah, just add 20 kW. So we've got so we had the range 1127. We had the 7463 for the lights. We had the 10K for the two dryers. We had 5750 for the motor loads. You know what we did? We did 25% of both motors, and that's not right. We got to back out a little bit, but we'll keep on going for now. I got to go back. I got to clean something up. And then let's see, what do we have for the, what else do we have? What else do we calculate here? We had the range, we had the lighting, we had the washer and dryer, the two motors. Is that everything? Did I put in the smaller half horsepower motor?
That's a 5750.
No, the 1127 was what that half horsepower motor was. 9.8 to 115. What was that? I don't know if I put that in there or not.
The blower motor was 1127.
Okay, yeah, so I did have that. So I got 24,340. 24,340 is what I got. Am I missing something, or is that it?
You got 24,000?
Oh, I didn't put I got 24,340 right now without the air conditioning, without the heat added, which would be 44,340. Let me make sure I got everything. So I got the 7350 for the square foot. I got the 9200 for the range. So I put that in there. Yeah. Two dryers at 10K. The motors at 5750. Got that. Fan at 1127, and so that's right. So 44,340 when it's all said and done. Because I had the 24,340 plus the 20,000 for the heat, 44,340 altogether. Is that what you got?
I missed something somewhere, I guess.
What do you have?
I'm just going back. I think I didn't write something else down. One of my notes here.
Easy to do. So the lighting load was 7463 altogether.
I got that, 7463.
And the range
10,000.
The night range was 9200, which was the next thing on the question. Then there was the dryer and the two motors. The two dryers were 10K. The two motors were 5750, which we did that one wrong, but I'll come back to that. And then what else do we have? Then we had the
blower motor
at 1127. And then the two heater air conditioner, which was the 20,000. So let me make sure I didn't add it wrong. 7463 plus 19.2 plus 5750. I must have added it wrong because I'm already getting something different. Plus 1127. That is way off. I must have not had mine all in there. 7463 plus 9200. plus plus 5750. 1127. I'll just add that again. That time I got 53,510. That's probably still not right because I think I added it something twice. 7463 plus 19.2 plus 5750 plus 1127 plus 20,000. All right, my final answer for the 14th time, 53,540.
That's what I got.
All right. So what size ungrounded aluminum service conductors would you size?
Ungrounded aluminum.
Hot phase conductors.
For 53,000. And this is a 240 volt.
There you go. But divided by 240 volts. So
223.
223. So that would be what size service?
Yeah. That'll be a 225 amp service.
Yep. 225 because you just round up the next. Well, do they make it? Yeah, they do make it 225. Round up the next standard size breaker size. And that would give you.
And you want aluminum at 60 degree aluminum. 220. Something good for 225.
What page are you on? What table are you using?
310/60.
310/60 or 16?
I'm sorry, 310/15 B16. Yeah.
If it was a commercial service, would there be a different wire size than a residential?
Yes. Because we can do 80% of 223, right?
83.
83%.
And that comes from 310/15 B7.
So that's 185.
Now, and remember, it's 83% of whatever that breaker size that you choose. So make sure you always round it up first, because if you do it against just the load calculation, it's going to be too small. So it'd be the 223 rounded to 225. Now, if some of them will be a bigger spread. This one will be pretty close anyway. But so 225 times 0.83 would be 186.75.
186.75, and that we want aluminum, right? Still?
Yeah, aluminum. Yeah.
So 195 amp aluminum at 60 degree is 300. What?
For 200 amp, you get 4-aught already, right? Probably not that far.
I lost you there.
Okay. Sorry, what I was saying was for a 200 amp service residential, I mean, you'd be at 4-aught aluminum, already. So this is 225 amps, so it would probably be a size or so, but you're at 186 on your calculation, 187 actually. So you don't have to use it. You're using the 6-degree column. That's what you're doing. You use the 75 because you're over 100 amps. You're 186, so you could use the 75-degree column, and that would be 250.
Okay.
250 kcm aluminum would be good for a 205 amp service, and we're we're at 186.75. Tried to use that service size to go back and do that, but that's not. Otherwise, I'd have the same table for commercial and residential, and there's just not there's not as heavy of a demand in residential as it would be a commercial feeder.
Right. Okay. And you said that we did both those motors at 100. What did you say? It was 125%.
Yeah. So I added added the 12 and the 24 to get, or I'm sorry, the 16 amps and the 24 amps together, and then did the 125. I should have only done it against the 24 amp one, and then added the 16 amps to that number, because otherwise I'm taking 100% of both, 125% of both of them. So it wouldn't have been 5750. It'd have been it'd been 24 times 115 times 1.25 plus, so it'd be 3450 plus 16 at 115. It actually would have only been 5290 instead of 5750.
Okay.
I just got too crazy. That would have been, the difference would have been so small by the time you would have sized the wire, it would have probably been negligible, but still, technically, it's wrong. So I ended up taking an extra 460 watts on that I shouldn't have, divided by 240 volts, which would be 1.91 amps extra. If that had been a 176.16 amp or 176.9 is my load calculation, that would have worked on a whole nother wire size against me.
Would have got you. Yeah.
All right. Well, what else?
Well, I don't know. I think it's a lot of
for me, the one, I guess, parting thing I'd give you, on the math calculation, you got enough time. I mean, it's evident that you were comfortable with your time because you had enough time to read everything, work your problems out. I mean, so I don't think you have to worry about being in a hurry, right? And so I would sit down. I would go through the whole test first, and I tell classes in the past that I don't really make a big deal about it now because it's kind of scary when you're on a 2-minute drill on the code calculations to try to do something like that. But if you're on a math where you've got plenty of time to spend on it or devote on it, I don't mind you spending the time and doing that, because what will happen is when you first go, let me see if I can find what I'm looking for. It's this right here. But I don't have a picture of it because it's messed up. That's just great. Let me see if I can find a different one here. So, when you're first sitting in there, did you use any of the functions at the top other than the mark button when you're sitting in there? Have you noticed those or messed with any of those?
No, I didn't. All I did was just mark the ones I wanted to go back to.
So there's a screen. Let me see if I can find a picture of it. But at the top of the screen, there is a like a little go-to button, right? And so that go-to button is real handy because if you put things in piles, you can go back and look at what's in each pile. Mm-hmm. And so if I'm doing motor calculations or I'm doing ground and bonding calculations, whatever they are, I want to do them all at the same time, right? To just get them over with. Doing them one by one and spreading other things in between them, you have to retool yourself every time you get to another one. So for example, if I'm sitting there and I've got 35 questions to go through, or 33 questions to go through.
33.
I would rather spend that first 20 or 30 minutes just reading what the questions are and kind of mentally prepare myself for how many of them are motors, how many of them are grounding, how many of them are appliances, so I can get a feel for the groups, right? The ones that are simple, you can go ahead and do those right then and there as you're going through them. That's fine. But anything that's really a long calculation, I wouldn't try to do it right then and there. I would just skip it. I mean, the minute you realize it's kind of getting to be a little bit of a complicated one, I would probably just hit next. Just it's enough for you to kind of know that that's either a motor or range or whatever it might be. And if you want, you can even kind of make notes on your little scratch paper there that as you're going through there and kind of put them in categories, how many grounding, how many whatever. But what happens is when you're done, there's a little button at the top of the screen that says go to, and if you hit the go to button, it can take you back to whatever view screen you want to do. So the ones that you got completed and when you first ran through there, the ones that were the simpler ones, when you go to the go to button, you can select the unanswered category, and what will happen is that it will basically only show you the ones that you haven't answered. Does
Okay.
that make sense?
Mm-hmm.
So it just kind of, and then as you go through and do them, every time you answer one of them, it will fall away and you won't see it again any longer, because you'll only be looking at the unanswered block. So what's nice about it is that you can kind of start, winnowing down the herd, and it's a little bit more comfortable feeling, because now you can kind of go back and forth without having to reread questions several times. So I start in the beginning, and I'm going through these things. I'm answering the ones that are the real simple ones, the ones that I know how to do without any problem. Anything that you feel uncomfortable about or you don't really understand or whatever it might be, it's good enough to just kind of get a gist of what kind of calculation it is, but keep on moving. Don't mark them though. Don't put any kind of guesses on them. Just leave them blank, right? And then when you get to that last one, the 33rd one, and you hit next, it'll say, do you want to end your test? And don't answer yes. Go to the top of the screen, and there's a little button that's marked go to. When you click on it, a little window pops up that says, okay, which one of these view categories do you want to choose? And I think the third one to pick is like unanswered. So it's answered, it's marked, and it's unanswered, or some order like that. So the unanswered category, when you click on that and then go to view, it will take you to the very first one that you didn't answer. And then again, like I said, all the ones that you don't want to look at again, they're out of your hair. And it'll keep you from going back and second guessing yourself on them too, on top of that, right? So it can sometimes happen. But then as you're going through there and you answer one and hit next, as soon as you answer it and hit next, it'll be gone. And now if you run out of, if you still have time at the end and you run out of questions to do, like you want to go back and review them, you go back to the go to button and hit all, and it'll take you back to the full screen again. So they're not going to go away for good. I mean, they're just out of your view, right? And then I try to do all of the like type questions together if I can, because like I said, it's easier once you get in the mind frame of doing ranges. If there's 2 or 3 range questions, I would do the first one I get to, and then I go, okay, there's 2 more, and I would just kind of scroll through there until I hit the next 2, and I just do them back to back. That way I'm in that mind frame. I'm tooled to do those, and I just knock them out. And the same thing, and then I just go back to whatever the next question is. If it happens to be another one of the groups like motors or grounding or whatever, then that will be the first one I do of those, and then I'll just keep skipping until I find the next one of them, and so on and so forth. Because I really think when you do them back to back like that, you catch yourself making mistakes from a previous one you just did. Which you might not even catch that if you're doing other problems in between the break there. You might not even remember you had that other motor question or something. So does that make sense as far as a strategy?
Yeah, trying to keep like questions together so you don't have to rethink what you already have in your mind. Yeah, I follow you. Yeah, that makes sense. Makes good sense.
You're not going to lose any time doing it this way, because you're still relatively doing the same thing, whether you're doing them one at a time or not. But of course, the other good thing is if you have a really tough one up front, you're not going to let it get you early in the test and you spend too much time on it, right? I mean, you'll just recognize it's not one and keep on rolling. So might save you from yourself a little bit.
Okay.
What else? Do you have any other just burning questions?
No. I think I have I guess through the end of the month to pass it. I'm going to try. I need to pass it tomorrow.
Are you so you're taking it tomorrow?
Yes, sir. 9:00.
Yeah. I mean, I don't, November 1st is when they're saying they're going to change it over. Right. So, if you don't pass tomorrow, not that I'm trying to put any pressure on you,
yeah,
but it's possible that it may roll over to the 2021, and if it, or the 2020, and if it does, I mean, there are some math changes that are going to come with that. I mean, we're going to calculate services differently than we are now. We'll calculate box fill a little bit differently than when we do now. But besides that, everything else will be the same. There's really not much that changes with math usually, unless it's, like some of the Chapter 6 stuff that changes all the time anyway, like the PV systems and stuff, which seems like they always rework those every year. Or every cycle, they're almost all new stuff. But
I wonder if that happens, is it going to be where I have to take the whole test back over
No,
again, knowledge?
no,
And
no.
no?
Your
Oh,
knowledge will be
good.
with you the whole time. Yeah. So if you pass one piece of it, you got that one, and they don't make you retake it. Even if they change a code, or even if your application expires and you have to renew it, it still carries over with you. So
Oh, good.
yeah,
Yeah.
yeah. So,
Well,
I guess what I'm saying though is you're in better shape if you don't pass the math than you would be if you were going to take the code part. Because if you had to take the code part again, you really would have just one shot. Because I mean that is a pretty significant change. But
yeah.
math wise, you'll be fine. We'll visit again if that's what happens, and we'll go over the new math, and you'll be prepared for it if you like. But I think you'll be fine. I mean, it sounds like most of the stuff we talked about tonight, you've been right on point on. So
You know, I've been doing this, almost 20, 25 years, and
wow,
this one, it's really got my goat because I go in there and I think, man, I got it, and then it just kicks you in the teeth, and it's like, man.
yeah,
So I have this horrible feeling about it that the first time, second time I took it, I was pretty confident. The third time is like, man, I thought I knew what I was doing, and now it's like, man, I don't. I'm even with all of this knowledge. I mean, your class I should have taken. If I wish I'd looked for it in the beginning because I would have taken it from the get go. But I just feel like I'm setting myself up for another failure. I don't want. I know I'm not supposed to feel that way, but
yeah,
and it's like you said though. This is what we do for a living, and I have a not too much pride, but I feel like I know what I'm doing in the
yeah.
field. I know how to run crews. I know how to do the work, but man, it comes to this, it's like, man, I just don't know what I'm talking about here.
Yeah, I mean, I'll tell you. I mean, even for me, sometimes I'll read some of those questions and I won't understand what they're really asking me. So don't feel bad. It's not. It's they really do try to test your basic knowledge of how things interact with each other.
Mhm.
So like they're not trying to be tricky about it. They're just trying to be vague about it because they want to know, do you understand the relationship? Whoa, look at that. Hi, how are you? See daddy? Why is he glitching up there? I don't know. I think the truck's about to run over us. Where'd you go? Are you still there? This just. I think the thing to remember about the whole deal is that it's just not. I mean, it's not a. Look at it like this. When you're a master, you're liable to be faced with any number of challenges that you'll have to be responsible for calculating. So, I mean, it's fair to test your understanding of the underpinnings and see how things are tied together. But don't let it get you down because these questions come at you from left field. I mean, they're not written like you would talk about them if you were doing it, in your office or in the field as a calculation, right? I mean, you
Yeah,
wouldn't use the terms or necessarily call it that way, but it is fair to some degree because when you're by yourself and you're responsible for it, I mean, you'll have to know these things and kind of understand what pieces kind of interact. And I think
sure.
that's the biggest part that I had to learn was kind of how do all these pieces tie together. And so I wouldn't let it get your goat. I mean, it's just a tough test. It's an open book test, and it's they got to do something to make it somewhat challenging. Otherwise, everybody'd pass it, and
Yeah,
then nobody wouldn't have any value in having the license at that point. So,
sure.
but you'll be fine. Don't I mean, it's easy to say don't let it get your goat. It's harder to not let it get your goat, right? So,
Yeah.
um,
But I
it's
definitely feel a lot better about it from the class that I took and then you helping out. And I truly, we simplified our life and sold what we had, moved to Corpus Christi so that we could live a little less on, I was making a really good living up there,
yeah,
but we wanted to do more in helping out in the ministry and things. And so I'm going to come here, I'll be able to take my test and then just working up to support what minimal we have.
yeah,
And it's like, man, with COVID and everything else, and I'm trying to work doing side work of sheetrock and drywall or whatever else I can do to help pay some bills,
yeah,
and then trying to study. It's like, and then, like I said, it's difficult, but I don't, I would, I get tired of interviewing people in the old job I had. and they would, well, I've been an electrician for 30 years. Oh, where your license? Oh, I never took my test. I didn't want to take my test. It's like, really?
Yeah.
Well, I don't want to fail. It's like, to me, it's like, well,
Yeah.
if I keep taking it, all I'm going to do is continue to try. And that's my goal, is that, it does depress me a little bit that I can't get it passed, but I'm going to continue at it until I get it passed. I'm going to keep learning until I can pass it. And that's, the more you take it, the more you get familiar with the questions, the more you get familiar with the code book. And my broken brain, sometimes that's what it takes.
I mean, look at it like this. It's forcing you to study this stuff, whereas once you're done, you're done. I mean, it can't be there is an upside to it, right? I mean, at the end of the day, you've really put yourself into the code book more probably than you have, in the last few years. So it's not a bad thing. I guess the one parting thought I'll give you, if this helps any, folks like you, when you get into that position and you do this last extra push, I've seen this pattern over and over and over again, where somebody will make a fairly middle to dismal score, 30 to 40%. They'll do that a couple of times, and then they'll have one fairly good but not quite passing. But almost every time, the next time they take it, it's like an 80%. Like I don't know what the combination of it is, but just everything kind of lines up and it starts making a little bit more sense. And that last test is just, it's almost always in the 80s, and it's low 80s, but still, I mean, it's a big jump between failing a test and scoring an 80 percentile, right? So,
right.
I feel really confident about it, because everything we've talked about tonight, you've been right on point. I mean, there's not been one single item except for that one motor question with the ambient temperature. I kind of got you a little bit there, but the rest of them, you were right on point. So I would.
Yeah, that's what it just. I got to slow down and read the question.
Yeah. There's a lot of
not get confused. Yeah.
There's a lot of that too. I will tell you that there's enough of that confusion. And so, are you familiar? You're comfortable with the demand load and the connected load, and when to calculate the feeder just derate, not the branch, all that stuff.
Yes,
we
sir.
talked about that in class pretty well.
Yes, sir.
Okay.
Yes, sir. And I, for you and your wife, I know you have a real job, a secular job than this. I really appreciate everything that you do. I mean, this is hands down, it's the best information I've ever come across.
Well, I appreciate that. Yeah.
And I definitely will, I will recommend you to anybody that I run into that's going to take the class or any testing or anything.
Oh, stop. No, I mean, like I said, I think I do it just because I don't know. I guess I kind of enjoy seeing people, win their challenges, and so for me, there's a certain amount of satisfaction of seeing people just like you, when you're just trying to beat your head against the wall and not getting anywhere, and being able to help push you past that. So, but give me a call tomorrow. Let me know how you do.
Okay, Mitchell, I sure appreciate your time, and you can have a good evening with your family.
You too, sir.
All right.
I'd say good luck, but I think it's supposed to be break a leg or something, but
just get it done.